Hi guys, today we're going to be looking at a question on momentum. A bullet moves east at a velocity of 480 meters per second. It hits a wooden block that is fixed to the floor. The bullet takes 0.01 seconds to move through the stationary block and emerges from the block at a velocity of 80 meters per second east. See the diagram below. Ignore the effects of air resistance. Consider the block bullet system as an isolated system. Question 4.1. Explain what is meant by an isolated system used in physics. So, an isolated system is a system on which the net external force is zero. So there's no external things acting on the system. The magnitude of the momentum of the bullet before it enters the block is 24 kilograms meters per second. Question 4.2. Calculate the 4.2.1 mass of the bullet. Since they give us the momentum and we know the velocity, we can use the formula P is equal to m times v in order to calculate the mass. We have the momentum being 24 is equal to mass, and we have the velocity before it enters the block being 480. And when we rearrange and plug this into the calculator, we should get 0.05 kilograms as the mass of the bullet. Question 4.2.2. Calculate the average net force exerted by the wooden block on the bullet. So, in order to calculate the net force, we can use the equation that F net delta T is equal to the change in momentum. We can therefore say that the F net, and we know the time taken is 0.01 seconds, is equal to the change in the momentum. So, the momentum of the bullet final minus the momentum of the bullet initial. So momentum being m times v, so the mass of the bullet 0.05 times the final velocity, which is 80, minus the mass of the bullet at the end times the velocity, which they have given us in the beginning as 24. We can then rearrange and we get that F net is equal to negative 2000 newtons. The negative just means that it's in the opposite direction. So we get F net to equal 2000 newtons west, as the bullet is moving east, so in the opposite direction would be west. And that's all for this video. Thank you.